Hey everyone, we're at the beginning of week 11. I'm going to start a approach on um, looping algorithms. Right, looping algorithms is actually next week, but this week we're going to be introducing syntax on repeating computation. So today is going to be all about for loops. And you know what? It might be a short day today. Right? The whole goal today is just to understand the syntax of a for loop and how to implement just a small one. Right? And this lesson will actually give us enough to get everything done, right? So this week we got the lesson 15, we have a lab 15, and a project, right, called a drawing. If you're curious what this project is, it's pretty much using the turtle, putting it inside of a loop so it can do something repetitively. So yeah, once again, we're covering for loops. We'll have enough to get the lab, and folks should be able to get a head start on this next project. Wednesday, we're going to cover while loops, but there's no associated labs with it. So for loops are the more important stuff, and this will allow us to implement some more algorithms next week. Next week is going to be kind of dense because we're going to be applying loops and actually computing things through large data sets. So make sure you were cool with the basics of loops by today. The basics of for loops actually. Yeah. Okay, so let's jump into it. We have lesson 15 and lab 15. So I'm gonna load those up. Okay, lesson 15 and also lab 15. Okay, once again, it's gonna be a relatively short day today. So I think we might have time to jump into the project, but yeah, we'll see. Okay, let's look at the lesson. So lately we've only been writing flat programs. Flat programs meaning that we had to put a statement a bunch of times. But it's possible to loop computation, right? Meaning that we can repetitively perform something. For this lesson, we'll be doing the for loop, which is a way of going through some going through a finite amount of items. Right? So let's say we had a finite amount of items, right? Like a list. So I'm just gonna go ahead and declare a list here, just like above here. All right, so I'm just gonna declare a list. Just put some random strings in here. Lions, tigers, and then bears. All right, so this is a list. I'm just gonna store it in a variable called animals, a list variable. Cool. So this is a finite amount of items inside of a data structure. Previously, if we wanted to access every element, right, we found ourselves printing over and over again, right? Like you might have seen yourself printing three things, right? Like animals, zero, and then animals one, and then two. Right? I'm going to delete this in just a bit, by the way. I wouldn't copy this three print statements down. Right? So if we were to access all of the elements, we just print them, right? Zero, one, and two. This can get kind of repetitive, right? Data as our data gets larger, right, our code will get larger as well. So we need to find a way to loop, right? And that's where the for loop comes in play. So here, let's write a for loop. Right? Basically, how a for loop works is you give it some sort of sequence, and then a variable that represents an element in that sequence. So, for example, if I wrote for something in animals, right, once again, something, this is a variable. So here, let's kind of deconstruct how this is working. Right, so for the for loop, we need to give it something that represents a sequence. Right, in this case, animals is a sequence. And we need to give it a name that will name each element in that sequence. So I just chose something. Right? It could be anything. Right? Basically, this variable represents every element, each individual element in this sequence. So I can access that element and just say print something. Right? Something. This is a string. Right? So something on the first iteration. Right? Iteration means a single loop execution. Right? So a single iteration, something became lions, and then on the second iteration, it became tiger, and then the third one became beer. Right? So something is a variable that represents each individual element. Okay, people cool with this so far? Yeah, so loops are good. Right? And just to talk about the indentation, when things are indented underneath this for loop, it's inside of the body. Right? So if I were to put like a print statement outside of here, right, like done, right, it doesn't matter what we put. Right? Basically, this statement is outside of the for loop, right, meaning it's only going to be executed once. Right? So I'll press play, and yeah, see how print's done once. But if it were to be indented, right, indented, so I'll indent it once. This now belongs in the loop body. So if I run it again, right, we see how it says done multiple times. So yeah, I just want to talk about the importance of indenting. Right, things that are indented are within the for loop's scope. Okay. Okay, people cool with this so far? Some for loops. All right. Let's do some more sequences. All right, so far we've only been iterating through a list sequence, right? But we could go through other things too. So let's see what other things we can do. And once again, this is the anatomy of a for loop, right? For some elements in a sequence, right? This name could be anything, by the way. This item, right? So just to reiterate that, right? This doesn't have to be something. You could call it like item, right? Meaning that we have to change this variable as well, right? You can name it whatever you want. Okay, so let's go ahead and do some more sequences. We just went through a list. It's possible to go through other things too, like strings, right? String is a sequence. It's a sequence of characters, right? Like each individual letter. A file handle is also a sequence. We covered file handles a couple weeks ago. Right? Basically, this each element in a file handle would be every line. Right? And then list, we just did that. Dictionaries, we haven't done this yet, but we'll do it in just a bit. Right? Basically, if we were to iterate through a dictionary, it's going to go through every single key, right? Not the value. It is possible to go through all the values though, but on default, it'll go through keys. All right, so we'll talk about this in just a bit. Let's do some more sequences. All right, like here, let's do a string. All right, so a string is a sequence. So I'm going to scroll down and just do one for a string. All right, so I'm just going to comment down here. Let's see, I'm just going to make a comment, say I'm iterating through a string. All right, so let's say we had a random string. All right, so I'm just going to say like text is equal to hello world. Right, it doesn't matter what the string is, but we can iterate through this sequence. Right, so we could write a for loop, say for something in the sequence. Right, here's going to be text, and I'm just going to print that something real quick. So print something. All right, so hopefully people kind of see what might happen. Right, something is every individual element in the sequence, so it should print each individual character line by line. Right, a better name for this something variable would probably be like letter, right? For or character, right? For character in text, print character, right? That's a better variable name. Let me zoom in a bit more. Are people cool with this so far? So we just did loops that go through lists, loop that goes through a string. All right, let's do a couple more sequences. All right, another one here. I'm going to make another code cell. All right, so let me just insert a cell below and do another sequence. Okay. Another sequence is a file handle, right? Like if we were to work with a file, like let me look up here. Let me see what file they're working with here. Files and then example.txt. So let me just see what that looks like. Oh, I need to go to lessons. I need to go to lessons directory. Files and then example.txt. Okay, cool. So this is a file that contains 5 lines. So let's iterate through each of these lines in the file handle. So here, let me go ahead and declare a file handle. So I'm gonna open this file up, right? Open example.txt. I'm gonna open up in read-only mode, just because we don't really plan on writing to it. Okay, and then store this in a variable called file handle. Okay, and as a good programming practice, make sure you close every time there's an open. All right, so I'm going to go ahead and close it at the bottom of the cell, right? Because we don't want too many open file handles. Okay, so a file handle is a sequence. Right? So that means we can iterate through it. So I'm going to write a loop that goes through each element in that file handle. Right? Because you remember earlier, in the couple weeks ago, when we iterated through every element there, we had to do a read line, right? Like you might remember we did like line 1. Here, don't type this. Line 1 is equal to something. I'm going to delete it. But you might remember we did file handle dot read line, right? And then we did that like 3 or 4 more times. Right? Like we have 5 lines here. I mean, so this can get kind of repetitive, right? And then if we were to print it, right, print line 1, and then print the other lines. All right, line 2, line 3, 4, and 5. All right, this should print everything in the poem. Oh, hold up, I got a file not found error. So no such file or directory. Once again, the path is incorrect here. Right? But basically, the path is relative to our lessons notebook. Right? So our lessons notebook is right here in the lessons directory. So we actually had to dive into this files folder first. So here, let me edit this path. Right? So it goes files and then the example. Okay, it should be able to find the correct one now. So let me run this. I just pressed play, and there we go. You see how it printed each individual line by line? All right, this can get kind of tedious. So we should probably loop all of this right here. Right? One cool way we could do it is with a treating the file handle as a sequence. Right? So we could say for something in file handle, right? File handle is a sequence. Right? So this something variable will represent each element in that sequence. So I'm going to go ahead and print it out. Okay, now I'm just going to press play. And there we go. See, we get the same exact thing. Right? Each element in the sequence represents a line. Okay. All right. Cool stuff, right? And once again, be careful for indents. Like if I were to accidentally indent this file handle.close, right, this is not going to give us the right functionality because the loop will iterate once, right? It'll look at something and then print it, right? But then it's going to close the file. Right? So be careful about this because then the loop will try to access the next element in the file handle, but we already closed that file. Right? So this is probably going to give us some error. Right? See this error, it says IO operation on a closed file. Right? So be careful with the indents, right? This does not belong in the loop. right? It belongs after the loop, when the loop finally finishes. All right. Hopefully people are cool with this so far. All right, so we just did 3 different loops. Right? One loop that goes through some characters. We did loops that goes through a file handle and also a list. All right, finally, let's do a dictionary. You might remember that dictionaries are data structures with a key value pair. So let me declare a random dictionary. Okay. I'm just gonna make another random dictionary. Oh, real quick, let me comment this cell. So this cell actually iterates through a file handle. All right, let me make another cell now. So press plus here to insert a new cell. And let me declare a random dictionary. Let's see. I guess we could pretend like we're dealing with student IDs. Right? Like pretend we have a dictionary. Right? So there we go. I just declared an empty dictionary called student IDs. Imagine if this dictionary stored key value pairs, right? The IDs to the name. Right? So for example, let's say that the number, let's say I'm just going to store these numbers as strings actually, just because we might have leading zeros. Right? Let's say someone had the student ID 0, 1, 2, 3, 4, right? And let's say this student ID belongs to someone named Alice. All right, and let me do another key value pair. All right, let's say 1111 is a student ID that belongs to Bob. And let me do another one. Let's go 2222. Right. Doesn't matter what these numbers are. And this is Charlie. Okay, so we have a dictionary that represents 3 different key value pairs. The dictionary is a sequence, and each element will actually be a key. Right? So if I were to iterate through the student IDs, right? So for something in student IDs, I'm just going to go ahead and print something. Right, so there we go. We just printed it, and you see what it did? It only printed the keys. Right, that's the default behavior when we're iterating through dictionaries. Okay, it is possible to print out the values too, right? Like something is a key, right? So here, a better name for this would just be to call this key. So I'm going to rename that variable to key. If we were to kind of access the value, right? Once again, this is a dictionary, so we'd have to put it inside of some square brackets, right? Because key allows us to grab the value here, right? So if I were to play this, right, you see how it's printing each value now, right? Alice, Bob, and Charlie. People cool with this so far? So this is iterating through a dictionary. Okay. I do want to expand on iterating through a sequence. Right? Let me change this back to key. Well, I'm gonna change this back to something. So earlier we just printed out the keys, which once again this is the default behavior of iterating through a dictionary sequence. If we were to iterate through each value, right? I mean, we just kind of did that, right? We did that by iterating through each key and using that key to grab the value, right? Like we did do student IDs and then something. Right, this does iterate through each value, but another way we can do it is by specifying the sequence a bit differently. Right, like if I were to say this dictionary dot values, right? Dot values is a class function that allows us that returns this whole list right here. Right, so here, you know what? Before I even play this, I want folks to see what the values are. Right, so student IDs dot values. Right, this gives us a sequence of these values. Right, so that's what those represent. You can also do keys as well. You don't really need to do this, but yeah, it gives us those a sequence of keys. Right, so we can actually use that values. Right, so now if we were to print something, it would be Alice, Bob, and Charlie. We're iterating through each value. All right, hopefully people are cool with this so far. But I'm going to switch it back real quick to its original behavior, where we were going back to all the keys. Right? So we don't specify the sequence and just leave it as a dictionary like this. Right? It's going to go through all its keys. So for key, and there we go, print the key. And let me just make this print statement a little more verbose. Like maybe I'll just put in an F string. Key is this variable, and then the value. Right, the value, we're going to index the key. Right, so it's going to be student IDs and then key. Right, this should just make the print statement a little more neater. So there we go. All right, we print out the key and then its corresponding value. Okay. I guess to make this a little more readable, you can put multiple statements in a for loop, right? Like maybe if we wanted to represent this in a variable, we can just say value is equal to this and just print out the value instead. Right? This means that every iteration, we're going to update value and just print it. So it's going to be the same thing. Right? All we did was move this to over here. Now you can have multiple things inside of a for loop, not just one statement. All right, people cool with this so far? Good old for loops. Okay. Let me see. We have enough to do the lab. Right, we just did a few examples. Right, we went through strings, we went through a file handle, a list, and a dictionary. Let me see if we have enough to do the lab. Almost. Let's go through some numbers. So numbers are also sequences. So we haven't seen this yet, but there is a Python function called range. Right? Basically, this range, right? If here, let's look at what range is. Right, so this is a classic, a native Python function. Right? It basically represents a sequence of numbers. So if I were to do the range 10, right? It just prints it back out. This is actually a list, right? If we were to convert this to a list right here, right, then it would give us a 0 all the way to 9. Right? So I just had to convert it to a list because it wasn't really displaying each element. Right, so just so folks see what range is, it goes 0 all the way to 10, but doesn't include 10. And so we can treat this range as a sequence. Right, so if we were to do like for something in range 10, and once again, range 10 is a sequence of numbers, so we can go ahead and print that something. Right, and we see it goes 0 all the way to 9. Right, it doesn't include 10. A better name for this would be number. There we go. So number, and then there we go. 0 all the way to there. Cool. Okay. Hopefully people are cool with this so far. So yeah, you can go through numbers as well, right? Not just the data structures. All right. We can get fancier with the ranges. Like if we were to specify an additional argument, right, it would represent another bound. Right, so earlier, our range function only had one argument, so it goes from 0 to 10. But if you want to control the left bound, then you can insert an argument on the left, right? Like if I were to insert like 5 as the first argument and then 10, right? It should go from 5 all the way to 10, right? But not including 10. Right? So yeah, that's the range function. You can also look at this documentation. You can do a lot of things with range. It can take one variable, it can take one parameter, it can take 2, it can take 3. Right? You can look at this. So Python functions. I'm just going to look at the Python functions here. And then primary documentation, built-in functions. So let's see the range. So here's the range. It's a native function. Right? So it kind of documents how to use it. Yeah, you can use a start, a stop, and then a step. Right? We haven't used a step yet, but basically the step just represents how many to go at a time. Right? The default is 1 at a time, right? But you can make it go 2 at a time if you want. Okay, so there we go. We just covered some numerical sequences. Okay, and you know what? I think we have enough to do the lab, actually. So here, let's go to the lab. See part 1. Okay. Yeah. Oh yeah. Go ahead and give this lab a go. There are a couple tricky ones that might require you to look at previous lessons, but you should be able to get most of this done. All right, so let's give it like 15, 20 minutes, and then we'll do this together in just a bit. I do want to highlight a couple tricky ones. Like this one is slightly tricky. The number 4. Number 4 is asking us to print every line with line numbers. But yeah, see what you can do. See what you can do. And then number 5. Oh yeah, this one is fine. Yeah, you should be able to do this one. Let's see, number 6, go through each word. Okay. Yeah, this one's a tiny bit tricky too. It's basically you're gonna have to use the split function, right, to treat this as a different type of sequence. All right, so just to give folks a little sneak peek into here, right? Sentence. If I were to print sentence, this is just a string of characters, right? But we can actually convert this to another data structure, right? There is a split function that's associated with a string, right? So if we do a string.split, it should default split on white spaces. So this should give us a list of words. All right. Once again, you can look at this string functions. Right, there's tons of string functions, but this is just one of them that we hit like on week 3 or something. Right, so basically, you might want to use the dot split to treat the sequence as a list instead, a list of words. Okay, so yeah, folks should have enough to do this whole lab actually. Once again, this is going to be a pretty short day, so let's give it like 15-20 minutes. We'll do this together, and we should have time to jump into the next programming project. But yeah, please give it a shot. So please try it out yourself because there are multiple approaches to do these parts. Okay, so I'm gonna do a timer. Let's give it like 20 minutes this time. And then we'll be back to go over this lab and introduce the next programming project. Okay, welcome back for folks on the recording. So we're gonna jump back into part 1, and we should have enough to get an intro to the homework. All right. So let's go on. The first part we did over here already, right? Basically, we hard coded a list and accessed every element in there to print it out. Okay, let's go ahead and do the next ones. These ones are asking us to pretty much use a range sequence. All right, in the previous lesson, we saw a function called range, which returns a sequence of numbers. Right, so if we were to do a range from 10, right, this would represent a list that goes 0 all the way to 10. So for number in range of 10, it's going to print the number. Okay, there we go. So print a number, and we see it goes 0 all the way to 9. Right? We do want to include 10. So, one way you can do that is just by changing this bounds to 11. Right, and there we go. We should print all the way to 10 now. Okay, there we go. And then this one is asking us to change the left bound so we can print from 5 to 10, right, instead of 0 to 10. Right, so there's a couple ways on doing this, right? I think, here, let's do a couple ways, right? One way is you can kind of just copy and paste this previous one that goes from 0 to 10 and write an if statement. Right, this is just one way, right? You can say, you can write an if statement, right? Like, only print the number if the number is greater than or equal to 5. Right? This is just one way. All right, so basically the first 5 numbers are ignored, and then the next 5 numbers are printed because this statement is true. All right, so this is just one way. A more efficient way is to kind of specify a more specific range. Right, so like this first one is kind of inefficient because it's the first half is being wasted. Right, but another way you can do it is just by specifying another argument, right? Basically the left bound here. And yeah, see, it's doing the same thing, right? 5 to 10, and then 5 to 10. Right, once again, this second one, the range function can take an arbitrary amount of arguments, right? It can take 1, 2, or 3. Right, if we use 2 arguments, it's going to treat this first one as the start. All right, so once again, I pulled up the documentation earlier on the range. Right, so this is the range. If we were to specify 1 argument, it would only work on the right bound. Right, but if we specify 2 arguments, the first one represents the left bound, the next one represents the right bound. Right, so that's kind of what we're applying here. Okay. Cool. File for loop. So this one wants us to print every line of a file with line numbers. Right, so here, ignore the line numbers for now. Let's just work on the file handle. Right, we want to open this file. Right, so let's go ahead and open it up. So we can go ahead and call the function open, and then I'm going to open up this path. Right, open, boom, and then I'm going to use read-only mode. Right, if you're curious what this is doing, it's going backwards. Right, the dot dot means go backwards. So it's going to go backwards into this directory, then it's going to go into lessons, right? And then it's going to go into files, and then example. Right, so example.txt is right here. Right, it's a poem with 5 lines. Okay, so let's go ahead and store this into a file handle. So I'm going to store this in a variable called file handle. This way we can access it and close it as well. So file handle.close for good program practice. File handle is a sequence. Right, we saw that in the lesson. Right, so let me just pull the lesson real quick. Okay, file handle is a sequence where each element is a single line in the file. Okay, so we can iterate through it, right? For line in file handle, right? You can call this whatever you want. I'm just gonna call it line because it's a better name, and we can go ahead and print the line out. Okay, there we go. So we printed out every single line in the file handle. But this question does ask us to print with line numbers. Right? One way you can do this is by declaring a variable to keep track of a number, right? Like, let's say we were to declare a variable that represents line number, right? And then maybe set it equal to 1. Right? Basically, the goal of this variable is to prefix each line. Right? So I'm going to go ahead and prefix each line. Let's go make this an F string. I'm going to go ahead and prefix each line with the line number and then a colon and then the line here. All right, so let's see what happens. All right, so I'm going to press play, and there we go. Right, it prefixed with a number, but we forgot to update the number. All right, so one way you can do it is inside of the for loop, we can increment the line number. Right, you can say line number is now increased by 1. Right, so it should get bigger on every iteration. So I'm gonna press play, and there we go. See, 1, 2, 3, 4, 5. Once again, this is just one way of doing it. There's a lot of other ways too. All right. Cool, cool. Okay, number 5. Let's see. Write a for loop that prints each letter. A sentence is a sequence of characters, so we can go ahead and iterate through that sequence. Right, for something in sentence. Right, a good name for something would be a like character. Right, this is probably a better name. Right, this variable will store each element in the sequence. We can go ahead and print it. So print a character, and there we go. Right, it should print out every element. Okay, let's see. Loop over words. This one's a tiny bit tricky. It's basically asking us to split the sentence and print out every word. Right, you want to split the sentence based off of white space. And there is a function called dot split. It's a string function, right? Basically, if we were to split this string, the default is going to be based off of the white space. Right? You can specify other delimiters too inside of this argument, but if you leave it blank, it's going to split based on white space. We can treat this as a sequence, right? A sequence of words. Right? So for word in sentence.split, right? So word will be Mary, word will be had. Right, then we can go ahead and print a word. Okay, there we go. We print out every single word there. Okay. Oh, just more on this split function. This split function is actually pretty useful, especially for data analysis. Right, like you might find yourself working with something called CSV files. Or CSV files are comma separated values. So CSV files, let me just Google this. Right, you might stumble upon a way of storing values, right? Like let's say you have data stored by commas, right? But basically you can split each line by commas, right? Like let's pretend that we had Mary had a little lamb, but I'm going to use commas instead. Right, just imagine this as data, right? Just we're storing strings. It could be numbers, it could be whatever, right? But if I just change it to commas, and now the iteration is only happening once, right? Why is that? Right, so let's look at sentence.split. Okay, once again, sentence.split delimits based off white space. So, whoops, get rid of that colon. Right, there's actually only one element in the sequence. Right, there's one element, one single string. It is possible to modify the split function. Basically, you can give it an optional argument. Right, I'm going to give it a comma, and it'll tell the function to split based off the comma. So if we press play here, right now we have 5 elements, and we can go ahead and treat that as a sequence, right? For data in this sequence, we can print the data. All right, Mary had a little lamb. Okay, cool. I hope people are cool with this. Okay, that was part one. Let's see what part two is. Okay, I'm gonna skip over part two and let folks try this out at home. We basically already did this in the lesson, right? Part two is asking us to iterate through dictionaries. We already did this in the lesson towards the bottom over here, right? We did a few different examples on iterating through key value pairs. Right, so go ahead and look through this example, and you should be able to do this part two on your own. Okay, so we're actually done with lesson 15 and lab 15. You should be able to submit it before the deadline. So we should have time to go through the project now. Right, so before I even jump into the project, I want to bring up an application that we did in class. Okay. Earlier in class, someone asked, how can I apply this to an application they're building? Right, earlier, someone wants, one of our students here wants to build an application to kind of manage their inventory. Right, so we ended up creating a scenario. Right, basically, we made a new folder called Store Simulator, and had a text file here. Right, this text file contains inventory. Right, and this inventory stores a product and an amount. Right, each line has two tokens, right, two elements. So an application would be to load data in from a file and work with that data. Okay, and we ended up doing something like this right here. Right, so I did kind of introduce a bunch of code to folks here, but basically we declared an empty dictionary, and our goal is to load the inventory into this dictionary. Right, so an application would be to open up this file and grab each element, right? Grab each key value pair and then insert it to the dictionary. Right, so that's what we're doing here. We basically declared an empty dictionary to store the data, and then we ended up opening that file and then doing some operations. Right, basically these operations are grabbing the line, right, and then we're splitting the line. Right, so we split the line, and then we're grabbing each element from the line and then inserting it to the dictionary. Right, this is useful if you're writing a program to manage inventory. Right, so this line, I'm going to go ahead and play it. Right, this cell, I mean. Okay, there we go. I just pressed play. It didn't output anything, but if we look at the product inventory now, let me just delete this. Right, product inventory. Right, you see how our product inventory is blank? Right, there's nothing in this dictionary, but now there should be some items in here. Our product inventory now has four key value pairs. Right, and that happened because we did some parsing here. Right, but basically this is parsing the line. Right, so once again, if you're curious what this is doing, we're going through each line in this inventory. Right, we're parsing the line into two different tokens. Right, tokens. Once again, this is splitting the lines based off white space, and we're grabbing the two tokens, the product and the amount. We're using those as key value pairs. Right, so that's what we're doing here. Right, we're saying, hey, insert the product as a key, and then set that to this value. Right, so yeah, this is useful stuff. Just a quick application. Okay, so we just did enough to jump into the project. Once again, this week is all about loops. The project is implementing a for loop. So we have enough to get this done now. Let's go ahead and download this project and take a look at it. Okay, so it is over here somewhere. Assignments. It's called Project Week 11 Drawing. So I'll go ahead and bring this. Go ahead and download this notebook and upload it to your server. I already have it. It's over here. So I'm going to give folks a minute to load it up. Week 11. Okay, there we go. I just loaded it up. I'm going to give folks a minute to boot it up. Let's see. Project Week 11. Okay. Okay. Let's jump into this project. The goal of this assignment is to use the turtle and draw some sort of cool shape. Basically, you can use a loop and have the turtle repeat a certain step and draw something cool, right? Like a spiral, right? You can do a spiral. That's one start. So let's talk about this triangle. Oh, this triangle has repeated statements, right? Something can be looped about here. Right? Like what's happening? There's three things. There's three things that are repeated here, right? Move, turn, move, turn, move, turn. It is possible to loop this into some sort of for loop that does something 3 times, right? Like here, let me go ahead and do this in a separate notebook, just so folks are comfortable with this. So I'm just going to make a separate notebook just for visualization. I mean, a scratch pad. I'm just going to treat this as a scratch pad. Let me go ahead and import the Jupyter Turtle real quick. Import. Okay. Just so folks are aware, you might remember that we did a function called triangle. Right, this was a while ago. Basically, we had a function called triangle, and if we were to call triangle here, so let me make a new canvas, and if we were to call triangle with a given size, like 30, right, it's going to draw a triangle. Oh, it didn't draw it right. Let's see. How can I draw it right? Not what the triangle should look like. U.new, triangle 30. Let me see, 1, 2, and 3. Huh. Oh, it's because there's a typo on this last line. This last line should have been a turn. Okay, so let me reload this function. Okay, there we go. See, we drew a triangle, right? And you can change the size of it, 50. Right, so folks, remember we did this a while ago? Yeah. This function has some repeated steps. This is happening 3 times. Right? We could wrap this in a loop that does something 3 times. Right? What's one way we can represent a loop that does something 3 times? You might remember range, right? Remember a range gives us a list of numbers, right? In this case, it's giving us a list that goes 0, 1, 2. Right? We can treat this as a way of iterating. Right? So if we say for number in range, right, number will become 0, 1, and 2. Right? We could use those as an iteration. So I'm going to go ahead and tab this. Right? This means that it's going to happen 3 times now. Right? The number is unused, by the way. This is an unused variable. But the point is the loop will happen 3 times. Right? It's going to happen 3 times. We're not using this variable. We're just going to move the turtle instead. Right, so I'll press play and press play here. And yeah, see, it's doing the same thing. Isn't that cool? Right, and once again, if we were to do it with a square, right, it's going to be very similar. Right? Define a square of some size. Right? Basically, it's going to be the same. Right? Instead of a range from 0, 1, 2, right, maybe 0, 1, 2, 3. Right? So we could go ahead and implement that. Right? For number in range of 4. Right? It's going to be the same thing, but we're going to turn 90 degrees instead. Right? tu.turn, and then let's go 90 degrees, right? A right angle. Okay, so let's load this function in and invoke it. So I'm going to go ahead and invoke it right here. Let me just take over this square, and then 100. Press play. There we go. See, we drew a triangle and a square. All right. Yeah, people kind of seeing the uses of loops. I mean, with the turtle, this is just a way of visualizing. But we should be able to write a loop that draws a spiral. All right, let's jump into the project now. Okay. Let's see. There is a pretty handy function here. You might find it useful later. But basically, this function generalizes the triangle and the square. Right? So earlier we wrote 2 separate functions, right? One to represent a triangle, one to represent a square. It's actually possible to combine these two, right? Combine these 2 functions and generalize it to a shape. Right? So that's what this function is doing here, right? It's generalizing a shape so we can specify how many sides we want, right, and how many turns we want. So basically, you could study this for loop later. Right? All it's doing is taking our arguments and drawing a specific shape with it. So, for example, down here, oh, here, ignore this rainbow colors for now. I'm going to collapse this. Oh, I can't collapse it. So let's use that shape function so people kind of see what's going on. So I'm going to declare a turtle down here. Right, let's say we were to draw a triangle. Right, there is a function written for us that can draw a triangle. Right, it's this shape function. Right, basically, we give it how many sides we want, right, the size of it, and how many turns. Right, this turns is pretty much representing the degrees. Right? It basically controls how much the turtle is turning. So if we were to draw a triangle, right, we can just call shape. Right, we can call shape, give it 3 sides, right, a size of 50, and then 1 turn. Right, this should give us a triangle right here. Right, and if we wanted to make it a square, then we can just modify this shape to 4 sides. Right, so 4 here instead, and see how it draws a square instead. So basically, this shape function is already given to us. Right? Once again, all it does is generalizing shapes into a different function. Right? This way, we don't have to make separate functions for every single shape. Right? So you don't really have to focus on this math here. Right? You can actually just black box this math away. All you need to know is how to use the function. So, we can do more shapes, right? Like once again, 3 sides of the triangle. Right? We can let's move it around. Now let me turn it and then make another shape. I think this is going to be a little interesting one. Right? 5 sides, and then let's see, and this side is 75, and then turns 2. Right? This is going to draw a what's it called? A star. Right? So it's drawing a star because we specified what type of shape. Right? There's 5 sides. This is size 75. Right? And then 2, once again, this is just controlling its turn. Right? It's kind of controlling the degrees it's turning over here. Right? So if we were to use just 1, right? So 1 for the turn. This is just going to draw a hexagon, I believe. Yeah, there we go. See, just drew a hexagon because we specified the turn as something else. I'm going to change it back to 2, though. Okay, there we go. Okay, I just wanted to show how to use a shape function a bit. Right? If we wanted to draw a square, right, it would be with 4 sides instead. 4 sides, so let's play this. And there we go, right? It drew a square, right? All 4 of them. Okay, we can use this shape function later. But once again, the whole goal of this assignment is to draw something cool, right? It's to loop something and draw something cool. So for example, you could draw this. Right? This is a bunch of stars. Right? The turtle, you can think of this as turtle moves, draws a star, right? Moves again, draws a star, right? And it does it over and over again. Right? Move, drawing, move, drawing. Right? So let's go ahead and build up to that. Okay. So let's see. Let's attempt to recreate this left spiral. Right? Let's not focus on the shapes yet. Let's pretend like they're just gonna draw a spiral without these shapes, right? So just a line that goes around. Okay. So let me go ahead and create a new canvas here. Right. Oh, and this is a solution cell. So don't forget your doc string here. Right. The doc string is a comment. Your doc string here. Okay. So let me go ahead and create this canvas. Let's attempt to make this spiral. Right. So the turtle starts in the center. You can imagine it as it's moving and turning a bunch. Right? So here, you know what? Let's do a circle first. So if we were to do a circle, right, you might think of it as moving and turning like a bunch. Right, so here, don't type this yet, but let's say we were to move 10 and then turn 10. Or actually, let me move like 5. Actually, no, I'll make it 20. All right, so see what's happening? It moved and then turned a bit. Right, if we wanted to draw a circle, then we'd have to kind of paste this over and over again. So you see how I pasted it over and over again? Right, move, turn, and it should get close to a circle. See, it moved, turn, right? It almost looks like a circle, right? And then let's go ahead and keep pasting. Right? Oops, messed up a bit. Messed up a tiny bit. Okay, there we go. Just paste it more. You see how we can kind of loop something to make it draw a circle? So let me delete all of this. Hopefully people kind of see what we need to loop. Right? But basically, we just need to loop this move and turn a bunch of times. Right? So let's go ahead and wrap this in some sort of loop. Right? So maybe we want to have it do it like 36 times. Or let's do it 20 times. So for a number in range of a 20, right? This means the loop will happen 20 times. And they're going to move and turn 20 different times. All right, let's test this. Okay, there we go. Just press play. You see how it's almost done doing the circle? It's almost done. Right? We just gotta increase this range a bit more. Right? It would actually be 36, right? Because 10 degrees times 36 gives us 360 degrees. So there we go. I just changed it to 36, and now we get a full circle. All right. So hopefully people kind of see what might go on. Right, this is just one circle. If we were to change this number, right, to like 100, right, let's look at the turtle, see what it does. So I'll go 100 and see what happens. Okay. So if you care what happened, it actually just overlapped the circle a bunch. Right, turtle is making a bunch of laps. So we could make this into a spiral. Right? But basically, if we were to make it into a spiral, we'd probably have to vary one of these numbers, right? Like maybe the distance. Right? If we study this spiral, we can see that the distance is getting larger and larger. Right? So assume the turtle starts in the middle. Right? You see how the move distance is getting larger and larger, right? Oh yeah, yeah. If you make this number too big, the notebook can't really handle it. Yeah, yeah. It's basically it can't keep up with the rendering. You're good. You're good. Anyways, if we were to draw a spiral, right, you can think of it as it's doing a bunch of circles, right? But while it's doing the circles, its move distance is increasing. You see how the spacing between the stars kind of increase within every iteration, right? So we could maybe vary the move distance, right? Like let's say we generalize this distance into a variable called distance, right? And let me keep this range small for now. Let me make this range like 50 for now. Just keep it smaller, right? So we want to make a spiral. Right? One way is to vary this distance. Right? So let's say I start distance at like 0, and then move it, right? Move it by the specified distance. Right? So it's actually not going to move. Right? The turtle starts in the middle. Right? Distance is always 0. Right? But what if I make it like like 1? Right? It should move 1 pixel every time now. Right, there we go. See, you can't see it because it's 1 pixel, but there is a circle somewhere there. All right, let's go 2. All right, 2. See, there we go. Got a little bigger. All right, basically, we need to kind of combine this. Right, one way is you can start it at 0 and then increase the distance every time we iterate. All right, so start at 0, and then when we finish the first move and turn, we could increment distance. Right, I'm going to increment by something small, like 0.5, or let's go 1 for now. All right, so 1, and then let's go ahead and press play. All right, okay, so kind of see what happened. So within every iteration, right, the move distance got larger. Right, so that's kind of where this spiral is being generated. Right, distance plus 1. This is like looking at this previous spiral. Right, the distance gets larger on every iteration. Right, the spacing between the stars gets larger. So it's actually getting too large, and the turtle is going off the arena. Right? I mean, you can increase the size of the arena, right? Or you can decrease the distance increment, right? Like adding by 1 made it too large. So let's try like 0.1, right? So let's see what it does now. So I'll press play, and there we go. See, it's a little smaller, right? Because we increase the distance by a smaller number. All right. So let's go ahead and make this iterate a little more, right? Let's try 200 instead of 50. So 200 instead of 50. Scroll down. See how it's like a spiral now. Right, so people kind of visualizing how a spiral can be made. Right? But basically, it's like drawing a circle, right? But instead of having a uniform distance, right? The distance increases on every iteration. Right? That's one way you can draw a spiral. Okay. So let's see. All right. There's a couple more things we could talk about, like the color and the shapes. Right. So the goal of this assignment is really to make something that looks similar to here. Right. You can get creative and just try out different things. Right. But let's make it a little fancier. Like if we were to draw a shape here, right? Like maybe each iteration, the turtle can dump a shape at its current location. So this is the part where folks are going to have to do it themselves, right? So I'm going to leave a to do here, right? If you want, you can dump a shape at the current location. You're basically going to have to reuse one of these functions up here. All right, there's a function here called shape, which allows the turtle to dump a shape there. All right, so see if we can invoke this function within the loop. All right, so I'm just going to put a to do here. To do for folks. Invoke the shape function. Right? If you invoke the shape function here, it's going to make it do something like this right here. Okay. What else? Let's talk about colors now. So there is a color wheel where numbers are mapped to a certain color. Right? Like 0 maps to a red, and then as we increase that number, right, it's going to change different colors right here. Right, like number 180 represents blue. Right, so it's we can use a number and control its color. Right, so like there's some examples here that you'll see. Right, like here, let me just uncomment all this stuff out. Yeah, you have to take a look at this demonstration here. All it's really doing is changing the colors and drawing different shapes. Right, so you see how there's different shapes here. Right, the triangle is red. Right, red can be represented as a number. Right, so let's see what number red represents. Right, 0. Right, so red is actually 0. Right, we don't have to use this string. We can say it's 0 instead. And in blue, let's see what number represents this. So blue is 240. 240. And then color orange. Orange is like 30. Right, so let's see what this does. So there we go, orange. Okay. And there we go. Yeah, see, it's the same exact thing. And so we can use this color wheel and kind of vary its color. So you might have to find a way to change the color here, right? Like one way you can change the color is by changing inside the loop, right? You can say tu.color is equal to something, right? So I'm just going to change it as something here, right? Maybe a better name for this would be current color, right? We don't have this variable current color set up yet, so let's go ahead and set it up. Right? It would be good to declare this outside of the loop, right? This way we can use it inside of the loop. Right? So let's say we initialize the current color equal to 0. Right? So if we initialize it to 0, this is saying that we're going to start at red. Right? So let's see what the spiral looks like. So press play, and oh wait, did I press play? Oh, size is not defined. Let's see what happened here. Tu.move. Oh, I think I accidentally pasted something. My bad. I accidentally pasted some code from a previous notebook. I think I did a keyboard shortcut. So let me just remove this. My bad. Okay, there we go. So let me press play. See how I was drawing it. All right, but basically, we have the spiral handled here, right? And the tu.color is being set to red every time. Right? What if we wanted to change a color? Right? Well, we'd have to increment this variable, right? This variable kind of keeps track of the color wheel. So, one way you could do it is by doing current color equals current color plus 1. Right? This is saying on every iteration, we're going to change the color by moving counterclockwise on this wheel. So let me see what happens. So press play. There we go. You see how it's changing color? Pretty sick, right? Okay. Okay, let's see. We got 1 more minute left in class. I hope this gives folks a head start on this. But yeah, feel free to get creative, right? You don't have to use this exact example. I actually recommend trying to make your own type of shape, right? But basically the spiral is handled, the color is handled, right? If you don't mind invoking the shape function, this way it'll actually draw a shape in between, right? Yeah, get creative, right? You can pull the pen up, you can put the pen back down. You can draw whatever you want, as long as it's inside of a loop. Okay, so with that in mind, I hope that gives folks a good head start. Let's take a look at the future of the class. Next week is going to be pretty dense. It's going to be very dense, actually. I might have to try to cram some of next week into Wednesday. All right, Wednesday, we're going to be doing some stuff on while loops. While loops is another way of iterating through something. And then next week, we're going to spend 2 solid days on algorithms. If anything, we're going to do some algorithms on Wednesday as well, just because next week is kind of dense. Right? Algorithms, we're actually applying loops to solve different problems. In particular, we're going to be looking through large data structures. Right? We're going to be iterating through a bunch of data and calculating some certain statistics from it. All right. So yeah, thank you everyone for coming, and hope you all have a good day.